Hello everyone, this is Utkarsh and I welcome you all to a session in which I'm going to talk about GAN. So this video will be divided into two parts. In the first part, I will give you the introduction of the GAN and tell you the theory part of the GAN. And in the second part, we will look at the code. So first, I will talk about the agenda for this session first. Firstly, we will discuss what are generative models, and then I will discuss about generative adversarial networks, including how it works and the need of it. And then we'll look at the advantages as well. Moving forward, I will tell you what are a few challenges faced by GAN. And finally, to sum up this session, I will discuss a few applications of generative adversarial network. I hope you guys are clear with the agenda. Now, without wasting any more time, let us understand what are GANs and start with the generative model. Generative models are nothing but those models that use unsupervised learning approach. In a generator model, there is a sample in the data that is input variable x, but it lacks output variable y. And we use the only input variable to train the generator model, and it recognizes pattern from the input variable to generate an output that is unknown and based on the training data only. In supervised learning, we are more aligned toward creating predictive model from the input variable, and this type of modeling is also known as discriminator modeling. And in a classification problem, the model has to discriminate as to which class example belongs to. And on the other hand, unsupervised models are used to create or generate new example in the input distribution. To define a generator model in layman term, we can say that generator models are able to generate new example from the sample that are not only similar to the example but are also indistinguishable as well. The most common example of a generator model is a navy Bayes classifier, which is more often used as a discriminative model. Other examples of generative model include Gaussian mixture model and rather modern example that is generated adversarial network. Now let's try to understand what exactly are GANs or generative adversarial network. Generative adversarial network or GANs are deep learning based generative model that is used for unsupervised learning. It is basically a system with two competing neural networks compete with each other in a zero or sum game to create or generate variables in the data. It was first described in a paper in 2014 by Ian Goodfellow, and its standardized theory was proposed by Alec Radford in 2016, which is also known as DC-GAN and also called as Deep Convolutional General Adversarial Network. And most of the GANs today use Deep Convolutional General Adversarial Network architecture consists of two submodels known as the generator model and the discriminator model. Generator model take a sample and generate sample of data, and discriminator model decide whether the data is generated or taken from the real sample using a binary classification problem with the help of a sigmoid function that give the output in the form of the range 0 and 1. Now let's go ahead and take a look at how GAN actually work. Now we will see how GAN actually work. To understand how GAN work, let's break it down. Generative means that the model follows the unsupervised learning approach and is a generative model. Now let's understand adversarial term with a typical example of detective and counterfeit. In this case, we have two adversarial. First one is counterfeit, which is a generator, and its job is to create fake $1 bill. Next one is detective or discriminator. Its job is to tell you if the bill is real or fake. We then start a game and keep track of who is doing good job and bad job. If the discriminator can easily distinguish between the real and fake $1 bill, then we will update our generator to do a better job. If the discriminator is failing and cannot tell the difference, then we will update the discriminator to do a better job. In the beginning, generator didn't know anything about $1 bill, so the output is random noise. However, discriminator also does not know anything, so it make random decision. Through time, one will do better than other, and this will lead us to improve other to do better. When the training has been converged, the discriminator can no longer tell difference between real and fake data. because the generator is creating samples that look identical to real data. This competition between zero and sum game between two models is what mean by adversarial. Now moving forward, network simply means for the training of the model, we use a neural network as artificial intelligence algorithm. So basically in GAN, there is a generator network that takes sample and generate a sample of data, and after this the discriminator network decide whether the data is generated or taken from the real sample using a binary classification problem with the help of sigmoid function that give the output in the range of 0 to 1. The generator model analyzes the distribution of the data in such a way that after the training phase, the probability of the making a mistake maximizes, and the discriminator on the other hand is based on a model that will estimate the probability that the sample is coming from the real data or not the generator. The whole process can be represented in a mathematical formula. G here is generator, D is discriminator, P data X is distribution of real data, P data Z is distribution of generator, X is sample from real data, Z is sample from generator, DX is discriminator network, and GZ is generator network. So let's take a look at the flowchart once again. So here we have the training data which is going to give the real sample, and the generator network which is going to generate the sample from the random noise. And the example then will go to the discriminator network where it is going to check if the sample that is coming is real or fake. So this is how GAN actually work. Now we will take a look at the training phase, like how generator adversarial network is actually trained. So it happened in two phases. In the first phase is where we train the discriminator and we actually freeze the generator, which means that the training set for the generator is turned false, and the network will only do the forward pass and there will not be any back propagation. Basically, the discriminator train with the real data and check if it can predict them correctly, and the same with the fake data to identify them as fake. After this, there is the second part where we train generator and freeze the discriminator. So we get the real from the first phase and we use them to make better from the previous state to try and fool the discriminator better. To understand this in a layman term, I'm gonna tell you a few steps for training, like how you should start. In the first step is to define the problem and collect the data. After this, the second step is you have to choose the architecture of GAN. In this step, depending upon your problem, you have to choose how your GAN should look like. The third step is training the discriminator on real data. So we train the discriminator with real data to protect them as real for a number of time of called epoch as well. And then we generate the fake input from the generator. In this step, we are going to generate the fake sample from the generator. And the next step, we train the discriminator on fake data. So whatever sample are generated from the generator network, we gonna tell the discriminator to predict the generated data as fake. So that's how we know that discriminator is actually predicting the value as correctly. And the last step is we train the generator with output of discriminate. Also, after getting the discriminator prediction, we train the generator to fool the discriminator. That's how we train the GAN to actually get our solution from the problem, which is like defining the problem. Now we will take a look at the training phase, like how generator adversarial network is actually trained. So it happened in two phases. In the first phase is where we train the discriminator and we actually freeze the generator, which means that the training set for the generator is turned false, and the network will only do the forward pass and there will not be any back propagation. Basically, the discriminator train with the real data and check if it can predict them correctly, and the same with the fake data to identify them as fake. After this, there's the second part, where we train generator and freeze the discriminator. So we get the real from the first phase and we use them to make better from the previous state to try and fool the discriminator better. To understand this in a layman term, I'm gonna tell you a few steps for training, like how you should start. In the first step is to define the problem and collect the data. After this, the second step is you have to choose the architecture of GAN. In this step, depending upon your problem, you have to choose how your GAN should look like. The third step is training the discriminator on real data. So we train the discriminator with real data to protect them as real for a number of time of called epoch as well. And then we generate the fake input from the generator. In this step, we are going to generate the fake sample from the generator. And the next step, we train the discriminator on fake data. So whatever sample are generated from the generator network, we we gonna tell the discriminator to predict the generated data as fake. So that's how we know that discriminator is actually predicting the value as correctly. And the last step is we train the generator with output of discriminate. Also, after getting the discriminator prediction, we train the generator to fool the discriminator. That's how we train the GAN to actually get our solution from the problem, which is like define the problem. Now, we will go ahead and take a look at a few challenges of generative adversarial network. The concept of GAN is rather fascinating, but there are a lot of setbacks that can cause a lot of hindrance in its path. The major challenges faced by GANs are the first one is the stability. So there has to be stability that is required between discriminator and the generator network. Otherwise, whole network would just fall. For example, in case that if the discriminator is too powerful and the generator will fall to train altogether, it won't be take sample to the discriminator and it will always identify them as fake. And let's say if the discriminator network is too lenient, so any image that would be generated by the generator network would make the network useless. The next challenge faced by GAN is can fail miserably in determining the positioning of the object in terms of how many times objects should occur at that location. Suppose we have a maze in which we have placed three dogs with two eyes, and sometime again we will fail to determine the positioning of the object in terms of it will generate an image with like one dog and six eyes. So that's kind of a problem that we face while looking on GANs. The next challenge is 3D perspective trouble. GANs as it is not able to understand the prospect. Also, it will often give a flat image for a 3D object. So that one challenge is we faced with GAN as well. And GAN have a problem of understanding the global object and it cannot generate or understand holistic structure. If we are talking about trees, if we are talking about flowers, that's a problem with GAN will follow. And last but not the least, new type of GANs are more advanced. Let us talk about that is deep convolutional network and are expected to overcome their shortcoming altogether. We don't have to worry about these. These are the shortcomings and be faced with normal GAN, initial generator adversarial network. Now they have become more advanced. They actually overcome the shortcoming. We don't have to worry about guys. So last but not the least, I want to talk about a few applications of generative adversarial networks. So the first one is prediction of next frame in a video. Let's say the prediction of future events in a video frame is made possible with the help of GAN and DVD GAN, or we can call as dual video discriminator GAN. GAN generated 256 by 256 video of notable fidelity up to 48 frames in length, and this can be used for various purposes including surveillance, in which we can determine the activities in a frame that get distorted due to other factors like rain, dust, smoke, etc. So the possibilities are immense with this. If you are able to predict the next frame in a video, that actually help in many things like surveillance, security, and we can predict outcome based on these frames and we generate from a video. After this comes the text to image generation. So basically objective and attentive GAN, which is also known as object GAN, perform the text to image synthesizes in two steps. In the first step is gathering the semantic layout and then generating the image by synthesizing the image by using a deconvolutional image generator. In the final step, this this could be used intensively to generate images by understanding the caption layouts and redefine detail by synthesizing the words. And there is another study about the story that GAN that synthesizes the whole storyboard from the paragraph. So that's actually very good idea to talk about GAN. And just give a few layout and caption based on that it will generate image for us. Talking about the next application, we have image to image translation. So Pix to Pix is a model which designed for general purpose image to image translation. So let's say we have two images, we have a real image and then we will have a generated image, which is basically a fake. It will be reconstructed to the previous image which was real. This is how image to image translation work, guys. After this we have enhancing the resolution of an image. So also called super resolution generator adversarial network or also known as SRGAN is a it is a GAN which can generate the super resolution image from low resolution images with finer detail and better quality. This is actually a very good application of GAN. The application can be immense, so you imagine a higher quality image with finer detail generated from a low resolution image. The amount of help it would produce to identify detail in lower resolution images can be used for wider purposes including surveillance. We can use it for documentation security, we can use it for detecting pattern, etc. And last but not the least, we have interactive image generation. So GAN can be used to generate interactive images as well. And computer science and artificial intelligence library, also known as CSAIL, has developed a GAN that can generate 3D models with realistic lighting and reflection, enabled by the shape and texture editing, and more recently, researchers have came up with a model that can synthesize a reenacted face animated by a person's movement while preserving the appearance of the face at the same time. There are a lot of more applications we can work on. This brings us to the end of the first part of the video, guys. We have learned what are GANs, how it works, and what are the challenges faced by GAN, including the application of generative adversarial network. And in the second part, we will jump to other code. Hello everyone, this is Utkarsh, and welcome to the second part of the video. We have already seen what are GAN, how it works, and how to train a GAN. Now we will see how we can build our own GAN. Here we are importing our important imports, and here we are we are initializing the image rows and image columns. We have used a 256 cross 256 image. That's why we have initialized it to 256. He- Here we have set the channel to 3. Channel 3 means it is a RGB channel which will generate a colored image. Instead of 3, if we set it to 1, then our model will generate a black and white image. So in this part, we have just initialized the image shape which we gonna create. Here we have built the generator model. This is our first neural network that we're gonna create. Now here we have added the sequential keras layer. Basically, generator model take input of noise or latent vector and produces an image. Noise shape is nothing but a one-day array of size 1000. We can also call it as a latent vector. Here we are defining our model. Here we are only using dense layer, but network can be complicated based on the application. For example, we can also use VGG for super resolution GAN. Now we are adding some dense layer, leaky layer, and batch normalization layer. In the dense layer, we have initialized the input shape to noise shape, and it shows that we are using an initially randomized string which is 1000 character long, and then we have used a leaky layer here, and then we used batch normalization. Batch normalization prevent number from blowing up, and in the activation function in the activation layer we have used a 10h, which gives output in the range of 0 to 1. Here we are reshaping our image shape, and then we are getting our summary for this model. This is the noise which our model will gonna take, and this is the image which our model will generate. Basically this is the generated image, and at the end we are returning the model with noise and image as the parameter. Next, we are going to look at the discriminator model. So discriminator model has given an input image. The discriminator output tell us the likelihood of the input image being real or not using binary classification. Binary classification means it will return in the form of true or false, or we can say 0 or 1. We can also call it say validity. Like we have given some image to the discriminator, and it will tell us the validity of the image being real or not. So discriminator function is similar to that of generator function. Similarly, the discriminator we will do the similar thing, except that would be kind of reverse for the generator. Here we have added the flatten layer, and in the input shape we have given image shape. Flattening is nothing but converting the data into a one-dimensional array for inputting it to the next layer. Because we are taking the final image as the input and trying to output one number between 0 and 1, where 0 shows that it's entirely fake image and 1 shows that it's entirely real image, and the discriminator basically gives the values between those two. And for the layer, we have similar thing over here. We have added a bunch of layer. Here we have given the image as input, and it is telling us the validity of the image being real or not, and at the end we are returning the model with image and validity. Here comes the training part of our model. We have built a train function with epoch, batch size, and save intervals. So here we are loading our dataset from a Google Drive. Basically, I'm using Fish dataset, which has 9,000 images belonging to the 9 different classes. I have saved that dataset into my Google Drive. Here we are converting our batches into two half batch of equal size. From here, our training of the model begin. So first we will say for epoch in range epochs. Here we are selecting the random half batch of real images. We are finding the index from the random image, and then giving this index to the X train which have all our image. This will return a random image from our dataset. Here we are normalizing our noise here. First we take the noise and make that noise equal to batch size. Noise is one day array of size 1000, as we have talked about it before. And then in this part we are generating a half batch of fake images. Generator.predict function just generate fake images with the given input noise. Then we are printing the shape of generated image here, and in these two lines we are finding the loss for the discriminator loss for the real and the fake image respectively. Here we are taking the average loss for real and fake images, it is a discriminator loss. Now we are normalizing our noise here first. We take the noise and make that noise equal to batch size. And here we are creating an array of all ones of size equal to batch size. And here we are calculating the loss for the generator. Here we are printing some message so that we can get track of how much part is done. In this part, we are saving our images if epoch mod save interval is equal to 0, which means if we are giving epoch to 1000 and in in the interval of 500 epoch, it will save our images. So now here we will look at the save image function, which will save image for us to view. Firstly, we are normalizing the image and image here, and then here we are generating some images and saving it in the gen image function, and then we are rescaling our generated image from generator. We are rescaling it between 0 to 1, and here we are plotting our image using subplot, and here we are denormalizing our images. We remember that first in the beginning we normalize our images. We normalize it at the beginning because the neural network find it easy to work with number in the range of 0 to 1 rather than working on bigger number. It just make training quicker. And then of course we are saving our generated image here. Then we are using Adam optimizer here. Then we are storing our build generator function into a discriminator variable. Then we are compiling our discriminator with loss of binary cross entropy loss compute cross entropy loss between true level and predicted level. We use this cross entropy loss for binary classification applications. Here we are uh, using matrix as accuracy, and then again we are storing our build generator function in our generator variable. Then we are also finding build cross entropy loss for generator, and this is our random input to the generator, and our generator will produce a image from this input. This 1000 is nothing but a latent vector or say noise. We have talked about it earlier. And then this generator function will generate a image. Here we are resetting the discriminator trainable to false, and after that we are checking the validity of the generated image generated by the generator, and then we are combining the result from both generator and discriminator function. So Z here is the result from generator and valid is the result from the discriminator. Z tells us about the generated image and valid tells us that whether that images are real or fake. And then we are at the end we are finding the binary cross entropy loss for the combined result. At the last we are running our training function which we created earlier, and here we are running our training function which we have created earlier. If you remember, here we have passed 1000 epoch and batch size of 32, which will save our images at interval of 500, and at the end this means that we are testing our model on GAN for prediction. So these are the output from our model. If we look at any one of them, this is the 1000th epoch. So it tells about the accuracy, like if that if the image is real or not. Also, it tells us the discriminator loss and the generator loss here. Now, if we look at the generated image which our model generated, it is not a clear image as our training data set is not too so large. If instead of 9,000 images, if we took more than 100K images, then it could show some better result. And also, this whole process is very much computer intensive. It depends on our system as well, how much time it will take to run our model. For this model, it took me around 1 hour and 15 minutes. So that's it from this video, guys. Hope you have understand the concept of generative adversarial network. That's all from my side.